In this question, you're asked to show that if R is a rational root of fx and a, b are relatively prime, then b must divide Cn and a must divide C naught. Okay, so first of all, we should try to put a divided by b into the function. So we have fa divided by b equals Cn times a by b to the power n plus Cn minus 1 a by b to the power n minus 1 plus dot dot dot, okay, up to the second last term, C1 times a divided by b plus C naught, okay. And of course, this equation, this function is equal to 0, right? Because a divided by b is equal to r, and r is a root of the function then. Okay, and now you may try to multiply b to the power n to both sides of this equation, okay, to both sides. When you multiply b to the power n to 0, okay, then we still have 0 on the right hand side. And how about the left hand side? If you multiply b to the power n to the first term, Cn times, right, a by b to the power n, you should have Cn times a to the power n plus the second term is Cn minus 1 times a to the power n minus 1, right? And b to the power n times 1 over b to the power n minus 1 is b, okay? Up to the second last term, multiplying b to the power n to a by b, right, is a times b to the power n minus 1. And the last term is C naught times b to the power n. And then, well, you can leave the first term on the left hand side and move all other terms to the right hand side. Then you may have Cn times an, right, on the left hand side equals C minus Cn minus 1 an minus 1b minus dot dot dot, all are minus, right, because you move all the terms from the left hand side to the right hand side. And the second last is C1 a times b n minus 1 minus C naught b to the power n. And then you can see in all the terms on the right hand side, now b is a factor of each of them, right? Okay, so you can take b out. Then you may have b times minus Cn minus 1 a to the power n minus 1, the first term, the second, okay, up to the second last, C1 a b to the power n minus 2, okay, and minus the last term C naught b to the power n minus 1. Okay, and now you can see that this b is a factor of Cn times a to the power n. Okay, therefore we have, right, therefore now you can see b divides Cn and a to the power n. And therefore, we may conclude that b can divide Cn because a and b is relatively prime, okay? They don't have common factors other than 1. So we have we have proved, okay, the first point here, right? b divides Cn. And then the next, okay, we may go back to this line, okay? Instead of moving all other terms to the right hand side, now we leave all the terms Cn an plus Cn minus 1 a to the power n minus 1b, the second term, right, dot dot dot, up to the second last. We leave all these terms, okay, on the right hand side, and only move the last term to the left hand side. And now you can see A, this A, this A, this A, right? A is a factor of all the terms of on the left hand side. So again, you can take one A out, okay, from each of the terms on the left hand side. So we may have Cn times A minus 1, A to the power minus 1 here, right? And the second term is Cn times n minus 1, right, times A to the power n minus 2, B plus dot dot dot. The last is C1 Bn minus 1, okay, equals minus C naught B to the power n. And so you can see that, right, A is a factor of C naught B times B to the power n. Therefore, A can divide C naught B to the power n, right? And again, right, A divides C naught because A and B are relatively prime. Okay, and therefore we have shown, okay, the first two parts, okay, B divides Cn and A divides C naught. And the last part you need to show is square root of 2 is irrational. Okay, and we can do this part by contradiction. Suppose, okay, square root 2 is equal to A divided by B, for example, right? And it is not difficult to see that, right? Square root is actually a root of this equation, right? Fx equals x squared minus 2, okay? If you put the square root 2 in this function, okay, you may get the function value equals 0. And therefore, okay, and then we can compare, right? Because the degree of this function is 2, so we can compare this polynomial function with c2 times x squared plus c1 times x plus c naught, okay? And you can find that by comparing the coefficients, right? You may have that c2 equals 1, c1 equals 0, right? And c naught is equal to minus 2, okay? If our assumption is correct, okay, if square root is equal to a by b, is a rational root, is a rational number, right? And it is a root of this function, then from the previous result, we may see that, okay, we will conclude that b divides c2, okay? The denominator of this rational number, right, divides the leading coefficient of the function c2, 1, okay? Therefore, b divides 1. Okay, what number will divide 1? Only plus or minus 1. Okay, and therefore b must be equal to plus or minus 1. And therefore, from our assumption, right, square root 2 is equal to a by b, then square root 2 will be equal to plus or minus a. This is an integer. This is an integer, right? Because we assume a and b are both integers. Okay, and therefore, this is a contradiction. This is a contradiction to the fact that square root of 2 is not an integer. Bye-bye.